simplifying algebraic expressions, maybe we should talk about what we call like terms and unlike terms. Bless you. Like terms are what? Terms that have the same variable, but that's not good enough. Variable, or could be variables, could be more than one, with the same exponents. That's the key, with the same exponents. So let's see. So these are like terms. So how about 5x? Well, maybe I should define unlike terms first. So I'm going to ask you, is this like terms or not? So let me tell you what unlike terms are first. Unlike terms, those are not like terms. That's probably the easiest way to write it. So if you're not a like term, you're an unlike term. Let's begin with this. 5a and 6b. Are they like terms or not? Do they have the same variable? No. So done right there. They must have the same variable to be like terms. So this is unlike. Uh, 3a and 4a, are they like terms?
Yes.
Do they have the same variable?
Yes.
Is the exponent the same for both a's? What's the exponent of a here? 1. What's the exponent of a here?
1.
Those are like terms. 6x and 3x squared, are they like terms? No. They do have the same variable, but how come they unlike terms? Exponents is different. 5x squared y and negative 7x squared y. Like or unlike? Like terms. Same variables, same exponents. 3x squared y to the third, 5x to the third y squared. Like or unlike? Unlike, different exponents. So to be like terms, you must have the same variable, and that's not good enough. That's good, but it is more. And the variable must have the same power, the same exponents. Now, how do we collect like terms? Combining like terms. Wow, there's a magnet like almost there. So the next topic is, how do we combine them? Combining like terms. Let's take this example. We're going to get you sick here. So you got sick and you got a fruit basket from your friends. In it, there's 3 apples, 5 oranges, and 2 bananas. You also got one from your aunt. Another fruit basket from your aunt. This has 7 oranges, 6 or 7 apples, 6 oranges, and 5 bananas. If you take these 2 baskets and add them together, put them in a bigger basket. There's the bigger basket. What do you have in the big basket now?
10 apples.
So you'll have 3 apples plus the 7 apples, which is what? 10 apples. 5 oranges plus 6 oranges, you'll have what? 11 oranges. 2 bananas plus 5 bananas, you have what? 7 bananas. So what we did actually, we looked at the first basket, we said in it there's 3 apples plus 5 oranges plus 2 bananas. That was in the first basket, right? And you added to it what's in the second basket, which is 7 apples plus 6 oranges. This is not 50, that's oranges. Plus 5 bananas. Now when you add them, notice we added the apples to the apples. These are like terms. That's how you group things. You look for like terms. The A with the A. They're the same type. And notice when we added them, we go, there's 3 plus 7, which is what? 10. And what happened to the A? Notice I didn't make it 10A squared. It stayed the same. 10 apples. Now we look at the oranges. We have 5 oranges and 6 oranges. That's 11 oranges. And the bananas, we have 2 plus 5, which is what? 7 bananas. And that's how we're going to add expressions, by collecting like terms. We're going to combine x's with x's, x squared with x squared, the number with the number. So let's take a few examples here. We'll begin with this. Are these two like terms? We add the numbers. What is 2 plus 3? And we keep the x. 2 plus 3 is 5. That's 5x. Again, not x squared. A lot of people want to make it x squared, something else. No. The x's stay the same. 7x plus 3y minus 4x. Let's find the like terms. Where are they? Nope. 7 and 4, right? Those are the like terms. You have 7. You took away 4. So what's left? What is 7 minus 4? 3x plus what? 3y. 8x squared plus 5x. I want to add to it 6x squared minus 3x plus 2. These two again are the same type. We put them together. What is 8 plus 6? 14x squared. These two are the same type. What is plus 5 plus a negative 3? 2x. That's a 2x, very good. And this number, there's nothing to add to it, so plus the 2. Well, if we give you this one. From a couple of sections ago, we learned about the distributive property. You can multiply this through. And you can multiply this through. So this becomes 2 times x, 2x, plus 2 times 5, 10. Let's take the plus 3. What's plus 3 times x? 3x. What's plus 3 times a negative 2? Negative 6. Now we look for like terms. These two are like terms. So that's a 5x plus 4. So when you simplify that expression, you end up with 5x plus 4. Minus in the front. Well, if there's no number in the front, what does that mean? Negative 1. So it's really minus 1. We just don't put the 1. 4x. And if you want that minus 6, you can write it plus a negative 6. Remember the minus? You can change it to a plus minus. So now let's multiply that. Let's take the negative 1 times the 4x. What's negative 1 times 4? Negative 4x. There's the plus sign. That's this plus sign. What is negative 1 times a negative 6? Positive 6. What you noticed here, you have a minus sign in the front, which means what? Take the opposite of all of these. Do the opposite. What is the opposite of something? You change all the signs. So inside that, I could have done that in one step by changing all the signs on the inside. That would make it what? Negative 4x plus x. Was that the same answer? Yep. So that's a lot quicker there. But this is the math behind it. So if I have 7x minus parentheses 3x plus 8, what is that going to equal to? This is the 7x. This minus sign in front of the parentheses is going to change all the signs on the inside. It's going to make that what? Negative 3x minus 8. Now let's collect like terms. What is 7x minus 3x? That's a 4x minus the 8. I'll try another one here. What is 1/2? Let's use fractions. X plus 6 minus 4. Any suggestion?
Don't give me fractions.
Well, you're going to see him. Let's multiply first. What's 1/2 times x?
1/2 x.
1/2 x. There's the plus sign. What's 1/2 times the 6? What is 1/2 times 6? The 6 is 6 over what? 1. 1 times 6. 2 times 1. What is 6 over 2?
3.
And there's the minus 4. Now the only like terms I see is this one and that one. So the 1/2 x still in the front. What is 3 minus 4? Negative 1. Couple more, then I'll throw a few fractions since you struggle with that one. I'm like those animals. I see a weakness, I go for it. You know? So it looks like fraction might be some of your weakness. So we'll get you better at it. Let's try that one. Again, you have a minus sign in the front. So the first part, leave it alone. This minus sign is going to change all the signs on the inside. So that will be what?
Negative x minus 4.
Good. Minus x minus 4. Any like terms do you see there?
2x and x.
What is 2 minus? There's no number, that which means what?
It's 1.
1. What's 2 minus 1?
X.
1x. We never put the 1. I'll put it for now, then I'll erase it in the next step. But it's really 1. And what's minus 3? Minus 4.
Negative 7.
Negative 7. On my math lab, if you write 1x minus 7, they will mark it wrong. They don't want to see the 1. Because they said, if you don't put the 1, we know it's there. Just like if your answer is 7 over 1 and you write 7 over 1, they'll mark it wrong because that's what? 7.
Is that an 8 or a 9?
That's a 9 here. This is A, and that's a 9, that's a 4. Notice there's nothing in front of this parentheses. See it? There's nothing. Which means you don't even need the parentheses. 4A, I'll just make it capital A if that's easier, minus the 9. Now let's look at the minus 2. I can take the minus 2 and distribute that as one piece. What is minus 2 times 3a?
Negative 6a.
Negative 6a. And what is minus 2 times a plus 4?
Negative 8.
Now we grab the like terms.
Positive 8.
14 minus 6, which is what? Positive 8a. Negative 9 minus 8,
Negative 17.
negative 17. I don't know why I came in. You guys don't need me today.
If we get that password after the expiration date, does it like erase all of our work?
No, if you see me, I'll show you how. You can still register after that. We'll put it there. You have it with you?
Yep.
Okay, we'll do it after. Yeah, if you get your access code now after the expiration, if you do it the wrong way, it will erase everything. So see me after, and I'll help you register actually. So this way your grade will continue moving forward there. Notice I have more than one set of brackets or parentheses here. I got parentheses and brackets, which means the same thing really, but you always want to work from the inside out. So there's the 5, there's the plus, there's the 2. Let's see what's inside the brackets here. Let's grab that negative 4 and multiply it through. What's a negative 4 times x?
Negative 4x.
And what's the next one?
Positive 12.
Positive, because that's negative 4 times a negative 3, positive 12, and there's the plus the 8x. Now let's take the like terms, group them together. So there's the 5, there's the 2, there's the square bracket. What's negative 4x plus 8x?
4x.
4x
Plus 12.
plus 12. Now again, let's take that 2, which is a plus 2, and distribute that. So there's the 5. What's plus 2 times 4?
8x.
Plus 8x. What's 2 times 12?
24.
Plus 24. We can grab like terms, put them together. I like to write the x in descending power, so I start with the highest power, which is what? 8x. What about 5 plus 24?
Was it 29?
Yep, and if you wrote 29 plus 8x is correct, but I like to write my answer in descending power. Start with the x and keep decreasing. If you have x squared, I'll put that first, then x, then the ones with no x.
I believe how neat you can write.
Me?
Yeah.
I try to be so you can see it. Usually I'm not that. Okay.